Okay, so this week, some of your stuff you are going to get an answer key, but with this assignment, I really wanted to correct it with you. So we are looking at pages 35 and 36. Hopefully, while you're correcting anything that you were like really confused on, um, hopefully I go over. Okay, so page 35, and you were doing numbers 5 through 31. So number 5, the factors for the number are 1. Don't forget 1. It seems kind of obvious, but it's definitely going to be considered a factor. And they like to put that one on the state test because they know you guys forget 1. So don't fall for their tricks, okay? So number 5, 1, 2, 3, 4, 6, and 12. Number 6, 1, 2, 5, 10, 25, and 50. And that's the other one. Always remember the actual number goes into itself. Another one that they like to put there to kind of trick you. Okay, so don't fall for their tricks. Number 7, 1, 3, 13, and 39. And number 8, 1, 2, 4, 8, 16, 32, 64. So just remember, even though greatest common factor sounds like it's going to be a big number, it's always going to be that number or less. Okay, so kind of opposite than the way it sounds. All right, so numbers 9 through 18, what we're doing is we're finding a number that goes into both of the other numbers, and it's got to be the biggest one that goes into both. So for number 9, the biggest number that goes into 40 and 48 is 8. Number 10 is 15. And let me just do number 10 to show you as one example. So we were working with 30. Oh, I totally did not give myself enough room. I could already tell. We were working with 30 and 45. Okay, now I may even miss one when I do this. So if I miss one, you put it on your paper and you show me next time, okay? Because I'm going kind of quickly and I definitely could miss one. So with 30, we have 1, 2, 3, 4 does not go in it, 5, 6, 7, I don't think goes in it, 8, 9, 10, 13, 14, 15, and 30. I don't think I missed one. Okay, but if I did, you make sure and you tell me next time I see you. Okay, so with 45, we have 1, not 2 on this one, 3, 4, 5, 6, 7, 8, I think 9, 10, 11, 12, 13, 15, 45. I probably missed one on that one. But if I pulled out a calculator, I probably wouldn't have missed as many. And you saw what my strategy was. I literally go through each number. With certain numbers, you start to see some patterns. Remember, if you add these two numbers, like 5 plus 4, if the number you get, like 9, is divisible by 3, which 9 is, then you know the whole number is divisible by 3. It's just a little trick. Remember 5s, if they end in 5 or 0, 10s if they end in 0, 2 if they end in an even number. So try to remember some of those tricks, and that might help you out. So our greatest common factor is 15. Okay, 1 and 1 are common, 3 are common, 5 is common, but GCF, greatest common, is 15. Okay, and it is kind of hard because it's easy to forget numbers. They're big numbers that we got to go through, but you got to do your best, okay? All right, I'm going to go quickly through the rest of to 18, okay? So number 11 is 5, 12 is also 5, 13 is 1, because there are no other numbers that are in common but just 1. So there's never going to be no numbers in common. It's going to, unless it's a 0. That's why I was thinking. Unless it's a 0. But other than that, there's always going to be at least 1 in common, the actual number 1. 14 is 14. I love when they do that. 15 is 12, 16 is 9, 17 is 4, and 18 is 11, okay? All right, number 19. So Carlos is arranging books on shelves. He has 32 novels and 24 autobiographies. He wants every shelf to have the same number of novels and autobiographies. So you are really looking at how many shelves Carlos could make and evenly have those numbers and not have just one book left over somewhere. Okay, and you're going to see these same type of problems. It'll be books on shelves or cards on shelves, or just anything that you can evenly divide two different amounts, kind of like our vests and the buttons example. So Carlos can have 1, 2, 4, or 8 shelves. Hopefully that makes sense. Number 20. So we have middle school band has 56 members, and the high school band has 96 members, and they're going to march together in a parade, but they have to look even. You don't want one of them to have rows of 10 and another to have rows of 5. They want them to look good. They're going down a parade path. I don't know if you've been to a parade, but think about the way you see the marching bands. They're all lined up. Well, if you add 2 different bands, you don't want where one line has an extra person just kind of chilling, marching with everybody. It would look pretty silly. You're like, what happened to that guy or girl? So we're looking for how many columns and how many marchers would be in each column. So 8 columns with 19 marchers each. Okay, hopefully you're starting to get this. All right, number 21. So we have football tryouts. Now we have 12 coaches. 12 coaches. We have 42 players. And they're going to split into groups. Each of the groups have the same number of coaches and players. So what is the greatest number? Now, greatest should be your key term. You saw greatest. You saw evenly split into teams. Those are your key words that tell you, oh, I bet this is a GCF problem. Okay? So what's the greatest number of columns in which the two, oh, I'm sorry. Forget what I just said. Try again. So each group is going to have the same number of coaches and players. There you go. I found my spot. What is the greatest number of groups that can be formed? How many coaches and how many players in each of these groups? So the greatest number between 12 and 42 is 6. Okay? So if you take both of these numbers and divide by 6, that gives you 6. Sorry, not 6, because 6 times 6 is not 12. That gives you 2 coaches. And that gives you 7 players. Okay, so it's not about making the coaches and players completely even in each group. It's having that number of group and then dividing back and saying how many people are going to be on each team. Okay, number 21, same process. We would have 21 plates, 3 spring rolls, and 4 cheese cubes. Oh man, this is making me hungry right now. That looks delicious. Hopefully you looked at that little picture. You know, if anybody makes homemade spring rolls, I'm just putting a little plug out there. I'm just joking. Don't make me anything. It's okay. I'm obviously just hungry. I'm ready to eat. All right, let's move on. So you had to do to number 31. We got a few to go. So 23, what they wanted you to do is write the numbers as the product of their GCFs and another sum. Okay, so kind of weird. I'm going to show you some examples if you got stuck here. If you totally got stuck on this section, what I want you to do is I want you to watch my first example. I want you to pause the video and I want you to try the other ones again, then correct your paper, okay? So if I'm looking at 56 and 64, what they wanted me to do is pull an 8 out. Okay, so we pull an 8 out of 56. Remember my last video. That's what you need to remember right now, my last video. So you pull an 8 out, and what's left is 7 from the 56. And when you divide 64 by 8, what's left is 8. Okay, so we turn this into a distributive property. There is a step in between if you want to see it. You're saying 8 times 7 is 56 plus 8 times 8 is 64. And then this is where we pull that 8 out in the front, and then this 7 and this 8 go here, and we keep the addition sign in between. It's a pattern. I know it might not seem like it makes a lot of sense, but see it like a pattern. Don't dwell on why. Don't dwell on what's happening. Why would you do that? Just see the pattern and try it. So if you need to, pause the video and see the rest of the answers. And then when you come back, I'm going to start writing these on the board, okay? Just so you can see the answers. I think it'll make it easier. So 24 should be 2 times. Remember, when I write a number, let me put 24. When I write a number in front of parentheses, I'm multiplying to everything on the inside. I don't need to write X here. Okay, they do in the book, but you know what? That's very elementary, and I think you guys are ready to start seeing it the way you're going to see it in the future. So, like I was saying, 2 times 24 plus 7, number 25, would be 6 times 5 plus 9. Remember, if this number isn't big enough, if it's not really the GCF, if you picked a number that was not, then these are not going to be the same. So if your number's smaller than a 6, you need to go back and pick the actual GCF, and then you'll get the right answer. Number 26 is 8 times 3 plus 5. Number 27, as usual, I run out of room, is 11 times 5 plus 6. Number 28 is 7 times 7 plus 9. Number 29 is 5 times 8 plus 5. And I'm not going to give you the answer to number 30 because I want to check it and see if you understood it. So consider 30 kind of like a pre-assessment. Let's see how you're doing. I'll check in with you, okay? So number 31, what Tasha is asking, so Tasha believes that she can rewrite the difference of 120 and negative 36 as a product of the GCF of the two numbers and another difference. Is she correct? So we've been doing plus, plus, plus. We've been doing addition. We've been working with positive numbers. Tasha's like, I bet I could do this with negative numbers also. I could do this with subtraction. Do you think Tasha is correct? If you are not sure, let's come back to our first problem that we were doing. I'm going to just switch this around. I'm going to make it 8 minus 6. So we know that answers 2. So if I take a 2 out of the front number, that's like 2 times 4. I keep the minus. I take the 2 times 3. So look, this means the same thing. 2 times 4, that's 8. 2 times 3, that's 6. I kept my negative. Then I bring my 2 in the front like we've been practicing. I pull my leftover numbers and I keep my sign. So 4 minus 3. What is 4 minus 3? It's 1 times 2. We still got 2. So Tasha's correct. We could do this with subtraction as well. Hopefully that makes sense. I can't wait to check your number 30, see how you're doing. Email me if you have any questions. Thanks, guys.